All right. Well, hello, everybody. My name's Ron Hull. I'm a global director for Carrari. I'm based just south of Sarasota, Florida. My topic today is designing glazing for windborne debris protection. And with Milton just hitting our side of the state, this topic's very fresh in my mind, as I'm sure it is some of yours. Okay. In terms of our AIA 1 hour training courses, we actually offer 10. This is one of the 10. And we also offer online training through the AIA. We have a course there and Hanley Wood. So if you're interested in any more trainings, just let me know. And just to start off, in case you don't know, who is Carrari? We're a Japanese company based in Tokyo, in Japan. And about 10 years ago, Carrari bought the DuPont glass lamination business. So now that the two companies have been one for 10 years. Our PVB brand name is Trosaful, and then our Ionoplast brand name is Century Glass. I know that Century Glass used to be called Century Glass Plus. Some people called it SGP, but today we just refer to it as Century Glass. And here's some of the applications that our interlayers are used in. And today I'm going to focus on hurricane glazing. So Carrari is a registered provider of the AIA. If there's any presentation material that you'd like a copy of, just let me know. Okay, the learning objectives today are to learn about the key building codes and standards that regulate glazing in windborne debris regions. Identify windborne testing requirements, including small missile impact and pressure cycling and fenestration systems. Learn about the benefits of wet versus dry glaze systems. Learn about glass railing requirements. Become aware of other considerations, including energy performance, acoustics, intrusion, bomb blast, tornado resistance, and sustainability. And then recognize performance attributes of laminated glass interlayers and how they make buildings resilient. And last, learn how laminated glass can contribute to the health, safety, welfare, and happiness of the inhabitants of the building. Okay, our program topics. Our first quick introduction to laminated glass interlayer types. I'm going to go through some building codes, some standards, some hurricane testing requirements, and then talk about wet versus dry glaze systems, and then the other considerations. And normally during a presentation, I'll pass out these glass samples so you can touch and feel the interlayer. But in general, the PVB is a soft interlayer and the ionoplast is a stiff structural interlayer. So there's basically three types of glass. First is annealed, also called float glass. It's great, but when it breaks, it breaks into some dangerous shards or splinters. So annealed glass really is not a safety glass. But tempered glass is a safety glass because it's 4 times stronger than annealed glass. And when it breaks into these small pieces of glass, so it's less likely to cause injury or cuts. And then there's laminated glass, which can be either used with either annealed or tempered glass. So what is laminated glass? It's simple. It's 2 or more pieces of glass with an interlayer or a foil, a piece of plastic in between. The main purpose is to retain the glass fragments to the interlayer if the glass does break, and also to help minimize glass flying related injuries. Like I mentioned, the interlayers come in both flexible and stiff structural interlayers. The most common interlayer is called polyvinyl butyrol, or PVB. It was first invented in the 1930s for automobile vehicles because all that was around then was the annealed or float glass, and was causing death and injuries during car accidents. So ever since the 1930s, PVB has been inside the glass of a front windshield. And initially, back in the 1930s, all the glass in the vehicle was laminated with PVB. One advantage of PVB, besides the safety aspect, is it blocks 99% of the UV. So your dashboard, your carpet won't fade. And then noise reduction. The softer the PVB is, the more sound it will absorb from coming inside the car or inside the building. In general, just adding PVB to a glass window or door will improve the STC by about 2 decibels. And we also have an acoustic PVB that improves the acoustics by 5 decibels in one piece of glass. The PVBs come in different colors and tints, and they can be printed out. Ionoplast was invented in the 1990s, specifically for the hurricane wind-borne debris regions. At the time, PVB was not strong enough to stay in the frame during some of the cycling testing, high pressure cycling testing. Ionoplast is 100 times stiffer, 5 times more tear resistant than PVB. It's available in ultra clear and translucent white. It's one advantage of it is if the glass has exposed edges to the environment. The Ionoplast weathers very well. We have 25 years of data now, weathering data in Hialeah, Florida, where the edges look great. It's also good for post-breakage strength, and I'll show a video on that. Like PVB, it blocks the 99% of the UV, and then it has excellent properties for the structural glass market. Okay, what's the difference between hurricanes, cyclones, and typhoons? There's really, I couldn't find any differences, but it's just where you are in the world is what you call it. So if you're in the Americas, we call it hurricanes. If you're like in Southeast Asia, India area, you'll call it cyclones, and then I guess you call it typhoons if you're in Western Australia and China. And this year, the reason I'm showing this chart is this year I did give a presentation in Australia and in China where there are typhoons, and I had to keep changing my terminology from hurricane to typhoon. Okay, what is wind-borne debris? It's really anything that's on the ground or on a building that is light enough to be flying in the air. And I'll show one video. Okay, so Hurricane Andrew in 1992 really kicked off the new building code requirements for hurricanes in Florida and in the United States. Hurricane Andrew caused significant damage in southeast Florida. As you can see, the U-Haul vehicle was upside down, just really, really bad damage. So this caused Miami-Dade to start developing building codes and standards for hurricanes. And on this slide, this is an actual building from Hurricane Andrew. You can see in some of the building, there's still a little bit of glass left, but most of the glass in this building is gone. So what happens is when you get air and water into the building from a hurricane or a storm, first of all, you have water damage in there, could cause mold. If you're renting the building, you're going to not be able to rent it until it can be renovated, etc. So this is one reason why we have new building codes. Okay, just quickly go through a couple of the hurricanes. This one is in Puerto Rico, Hurricane Maria, Category 5. This one had really bad, this was in 2007. This had both bad wind damage and flooding, as you can see. And then next was Hurricane Michael, hit the panhandle of Florida. Started at Category 4, I think it ended up being a Category 5. Actually drove through parts of this state a month after, and it was just massive destruction, both wind and in water. I guess one bright spot from that is that there was a house right on the beach that was still standing. Some people call it the home still standing. And we did a case study on this building. It was built 6 months before the hurricane. It included our ionoplast materials in all the doors and our PVB in all the windows. Okay, here's one in Louisiana. This on the left is the building before the hurricane. Laura on the right is after. So you can see that after the hurricane kind of looked like the building in South Florida, from 1992. All right, here's Ian. This one hit my side of the state. Really significant wind damage where I was, and then horrible flooding and um, uh, damage to Fort Myers Beach, Sanibel Island. This was really tragic, and to be honest, there's still a lot of people recovering and still rebuilding from this one. Okay, then I mentioned I was actually in Guam recently doing a presentation, and in that part of the world, they actually have some pretty strong typhoons as well. This was 180-mile-an-hour sustained wind that was ready to hit Guam. All right, and then here's some more pictures from that storm. Okay, so Saffir-Simpson came up with a scale for hurricanes. You've probably seen this before, but you start off with a tropical depression about 39 miles an hour, and you end up with a Category 5 hurricane at 157 miles an hour. And just think that at one time, Milton, that would just hit Florida recently on the west side, when it was in the Gulf of Mexico, it had sustained winds at one time of 180 miles an hour. So there's actually been talk about adding another category because we're seeing much higher sustained wind speeds than 157 miles an hour. I think what's even more important is you look at the storm surge. There's really no storm surge for tropical depression, but the storm surge for Category 5 could be greater than 18 feet. And that's really what hit Fort Myers about 2 years ago. Okay, just for the fun of it, I went back to see what were the most high wind hurricane and typhoons ever. And so I highlighted in blue on this chart the ones that were above 175 miles an hour. So remember, so Category 5 is 156. So there's been many Category 5 hurricanes that have been with sustained winds above 175 miles an hour. And so I need to add Milton to this one as well. Okay, next is in terms of damage to buildings and deaths from the hurricanes in the U.S. So Katrina was by far the most expensive hurricane ever. That one hit Louisiana, Mississippi, and it also had 1,833 deaths. So Katrina was by far one of the worst hurricanes ever to hit the United States. And then looking at damage, you had Harvey, Ian, and Maria all well above $100 billion in damage. And then in terms of deaths, Puerto Rico had the most deaths, 2,981 from Maria. Okay, so there's many wind zone maps out there. This one is the ASCE showing the hurricane-prone regions of the United States. So really, it's from South Texas up to Maine, and covers all the Caribbean islands, Guam, and Hawaii. Here's another map showing this is 3-second gusts. So if you look at 3-second gusts for hurricanes, Guam's actually the highest at 210 miles per hour, and then followed by South Florida, which is over 200 miles an hour. And then here's the Florida wind debris regions. As you all know, South Florida has the highest speeds, wind zones. And actually, if you look at far west on this map, the Panhandle, you have some pretty high winds as well. And then FEMA, who's really involved in the aftermath of the hurricanes, they also have some wind zones, and their category wind zone, 150 mile an hour, includes Broward, Martin, Miami-Dade, Monroe, and Palm Beach counties. Okay, now moving on to building codes. I do see one question. Oh, yeah, so yeah, I forgot to mention that. Yeah, the building that I showed in Lake Charles, Louisiana, um, it actually imploded um, and is no longer there. So um, thank you, anonymous person, for for noting that. Okay, so the in Florida, the main building codes are Miami-Dade um, and the Florida Building Code. The rest of the world, except for Texas, uses the International Building Code. So if you're parts of the world where there's Miami-Dade and Florida and Texas don't apply, then the IBC really regulates any area where 135 mile an hour wind zones or higher occur. So Miami-Dade has its own standards, TAS 201, 202, and 203. And then once a product manufacturer has passed all the testing requirements and paperwork, then they are issued a notice of acceptance or an NOA. Florida Building Code does reference Miami-Dade, but it really uses ASTM standards, E1886 and E1996. And you get a product approval from the FBC instead of an NOA from the Miami-Dade. All right, so Miami-Dade, I mentioned a TS201 is the small and large missile impact testing standards. And 202 is air water structural testing. And then 203 is the cyclip pressure test. And then, like I mentioned before, you get an NOA once you passed all the requirements. And then ASTM 1886 is the test method for hurricanes, and then 1996 is the standard specification for performance. Okay, so what's the difference between TAS and ASTM? Well, TAS definitely, in my opinion, is more difficult to pass, and there's three reasons. One is the large missile, impacts the specimen twice, where ASTM you only have to impact the specimen once. The pass-fail criteria are the same. No penetration or opening larger than a 1/16 of an inch by 5 inches. However, ASTM says, or an opening through which a 3-inch sphere can freely pass. And then the other difference is Miami-Dade, the missile has to impact the mullion, at least 1 mullion, where ASTM, that's not a requirement. So looking at, this is from ASTM. So the first thing to note is the first 30 feet of the building is where you have large missile requirements. And that's mainly because a large missile like a 2x4 probably isn't going to fly higher than 30 feet. It may, but it may not. But the lighter missiles like gravel or anything that's lighter may fly higher than 30 feet. So we call that small missile. So that's a little background on that. And then when you're looking at designing a building, you have to look at many things. One is, what wind zone are you in? And what level of the building you're designing it to, and then whether or not it's an enhanced facility or just basic protection. So for example, if you're in wind zone 4 and you want enhanced protection for essential facilities, the first 30 feet of a building needs to be level E. And I'll cover that in a minute. And here's some of the buildings that fall under essential facilities. You have hospitals, healthcare, police stations, emergency shelters, jails, detention centers, etc. Okay, so the next chart, the table on the left shows the five missiles. Missile A is the small missile. That's 10 steel um, balls, 2 grams each, flying at 89 miles an hour. And I think most people, the first 30 feet of a building, most people test to level D, which is a 9-pound 2x4 going at 34 miles per hour. And then if you're a essential facility, you got to test level E. It's the same 9-pound 2x4, but the missile is going 55 miles per hour instead of 34. The table on the right, right top, is just a little guidance for which inner layer thickness and type would be needed for each level. Okay, then we have a brochure with lots of useful information. I pulled some of this out of our brochure. So this is general guidance. So, when to use PVB versus ionoplast. And so basically, once again, this is just general guidance. But if you're 80, your design pressure is 80 PSF or less, and your window size or door size is less than 30 square feet, then PVB should work. When your design pressure is higher or your glass sizes get bigger, that's when you need to consider using the ionoplast, because the PVB will pull out of the frame during the cycling test. Okay, you've probably seen this before, but this is the level D large missile impact test, the 9-pound 2x4 going at 34 miles per hour. See, so the objective is to have really no tear when the glass breaks, and none of the glass comes out of the frame during the impact. Okay, the small missile test is, like I said, 10 2-gram steel balls shot out of a cannon at 89 miles an hour. You do 3 impacts. There's a picture just showing what it looks like after the steel balls hit the glass. And here is an actual pressuring test. Whoops, I'm sorry, I skipped a slide. So the pressuring is pretty simple. You test it 4,500 times in the positive direction and then 4,500 times in the negative. Each duration is 1 to 3 seconds. And really you got to get with normally an engineering firm to determine what pressures for each of these different cycles. But basically, you got to cycle the glass 9,000 times and have none of the glass pull out of the frame. So here's a sample of the cycling test. I'll do it one more time. So you have the glass already broken. Now you have the system attached to the wall, and there's a pressure being pulled from the wall, and the glass is deflecting. Okay, one more topic I wanted to cover that is related to the hurricane testing is there are some now flood-resistant windows. So I think it's a little bit similar to hurricane, but in this test you have to first impact it with a log. You can see a picture of the log that swings down and hits the glass. And then you got to fill a container full of water up to 10 feet and have no water leak out of the container. So this is FM, Factory Mutual, and ANSI standard 2510 is one of the main standards to look at. FEMA also has a standard for floodproofing, but this is a big trend we're seeing, is to have not only a hurricane-resistant system, but also a system that can withstand flooding. So this is a example of a passive system. It's actually it looks like a glass railing. This is along a river, but they in the city they installed this. This is actually a flood barrier, where if the river does crest and goes above the ground level, then now you have, instead of sandbags, you have a permanent structure here to prevent the water from coming farther inland. Okay, I see a question. Okay, does Broward County still have requirements more stringent than Dade? I don't think so. I think Miami-Dade um, includes the 3 counties. So, no, so I do not believe so. If someone else has some newer information, let me know, but I don't think so. All right, so for glass railings, very popular in Florida and in the hurricane region. So before 2015, all glass railings typically were tempered glass. And because tempered glass sometimes spontaneously breaks, or it might just break from an impact and fall off a building, it's the International Building Code decided to change the glass railing specifications from tempered to laminate glass. So this all started in 2015 with IBC. The state of Florida has its own standards. These are the standards for glass railings. There's a picture of some nice glass railings in Florida. So I want to show a quick video. In this video, we're going to show a glass railing in a one-side supported, only supported in the base or the shoe. And we're going to test tempered glass with a stick-on film, laminate glass with PVB, and laminate glass with ionoplast. So this is tempered glass. This is what tempered glass looks like when it breaks. There's another angle of the tempered glass. So see, it breaks into small pieces, which is nice. Here's an applied film, stick-on film. All it really did here was it kept all the glass together. Here's PVB. So PVB, see, almost no glass falls onto the sidewalk, but the glass falls over like a wet noodle. So if there's a child up there, they could easily fall off. Here's the ionoplast. See, the glass does break, it deflects, but then it just pops up in place. So it can be a barrier until you get the glass replaced. Okay, then here's another popular design. I just want to show this one. So this is once again tempered glass. In this case, this railing is only supported by the 4 points. Here's the applied film, stick-on film. Here's the PVB. See, the PVB eventually does fall off onto the ground. And then the ionoplast is next. So we actually were able to hit this 10 times and the glass stayed in the frame. So this is what we call post-breakage strength. Okay, now I mentioned something called spontaneous glass breakage. So this was a camera, security camera on the street, just happened to catch this glass railing breaking. So if you look up top in the video when it comes out, see the glass railing, the glass just broke for no known reason. Now there is something called nickel sulfide inclusion. It is an impurity that's sometimes in the glass, and when the glass is tempered, it can spontaneously break if there's too much of this nickel sulfide inclusion in there. One way of preventing this, it's not guaranteed, but you can heat soak the glass after you temper it. But this is one reason why glass railings are now laminated instead of tempered. Okay, so next certification. So Miami-Dade, so like if you're a window door company and you pass all the testing, you get all the paperwork done, you meet all the requirements, you get issued an NOA. And you can actually go onto Miami-Dade's website or the state of Florida's website and look at all the NOAs and all the product approvals that have been tested. It's a really, really good system, and in my opinion, it's pretty user-friendly as well. And then the Texas Department of State has their own, I'm sorry, the Texas Department of Insurance has its own requirements for windstorms. And in some cases, if you've done all the testing to meet the state of Florida or the Miami-Dade requirements, then Texas will allow it to be used in Texas without additional testing. Okay, then in case you do need designing in Texas, it's basically the coastline of the entire Gulf Coast of Texas. And I mentioned, so here's just a sample of the websites where you can go and pull up any NOA or product approval that's been tested. And here, so we're a product manufacturer, so in Miami-Dade we also have to have an NOA. So this is a sample of what our NOA looks like and some of the testing that is required. In the state of Florida, we're not required to have a product approval. This is only for Miami-Dade. Okay, so one of the issues with laminated glass that you should be aware of, unfortunately this is not common, is to see if there's any delamination where the glass is separating from the inner layer. So the picture on the top is a looks like a point supported system. You can see around the point there is some looks like a white star kind of. That is the glass is separating from the inner layer. And then above that, where there's, I think this is structural sealant, you're seeing delamination as well. And then the bottom is a piece of glass showing delamination on the edge. Right, so I travel a lot out of the different Florida airports. So this one actually took out of the Orlando airport, not the new terminal, one of the older terminals. You can see this is a bucklay system where you have a sealant in the vertical, and there's bubbles, delamination on both sides of it. Now, I don't know why this is happening, but one theory is that the sealant is not compatible with the inner layer. I think in this case it's PVB, or somehow water got entrapped into the sealant. And then the picture on the right, where you see white on the bottom of the framing system, when PVB gets really wet, it turns white. And so what you're seeing here is, my guess is for some reason this system isn't draining right, water stuck in there. Maybe the seat poles got sand in them or bugs. But I've done no forensics on these, but these are just my theories. And then on the left is a picture I took from the Fort Lauderdale airport. Something's going on with the vertical mullion. So I'm not sure what's happening here, but this is not good. And then the picture on the right is from Miami International Airport. You can see some delamination occurring around all the edges. So, unfortunately, this is not common, but if you do see this, this is not good. Okay, so now talking about some project types. There's many I'm going to cover coming up, but first I want to talk about wet versus dry glaze systems. So a wet glaze system, it's pretty simple. So if you're outside of Florida, normally a window or door is the glass in the door is installed with a gasket. But in the hurricane testing, the cyclone testing, you want that glass to stay in the frame. So one way to keep the glass in the frame, especially with the PVBs, is to have a sealant that basically glues the glass to the frame. So whenever a sealant is being used, it's called wet glazed, and then when there's no sealants, it's called dry glazed. That's an easy way of saying it. And one of the advantages of a dry glaze system is if the glass does break or has to be replaced, You don't got to dig all that sealant out of the frame. You just remove the glass, remove the gasket, and put a new one in. So, and there are some systems actually, because of the stiffness of ionoplast, that are dry glaze for the hurricane regions with ionoplast. Okay, here's a couple dry glaze projects around Florida. I see another question. Okay, I'll stop here. Is ICC 500 wind zone of 200 miles an hour can work with level E? It requires testing 100 miles an hour. Do you have something that passes that? Yeah, so I'm going to be covering the tornado testing in a couple slides. So I'll cover that then. But yes, yeah, we've worked with a couple companies, Collier and Windco and others, to have um, a window door curtain wall that can withstand a high level tornado. And that's a good question because during Milton, we evacuated to Miami area, and so we missed the hurricane, but there were a lot of tornadoes from West Palm Beach down to Miami. Okay, then next question: have you heard anything on FPC changing the entire state to be HVAC? I've heard a rumor about that, but I don't think it's true. Um, but yeah, I think that's a rumor, but I don't have any evidence it's true. The next one, not a question. When my daughter was re-roofing her house in Houston, I told her to make sure the packing for the shingles had Miami-Dade approved on the packaging. That's a very wise parent giving a daughter that information. Okay, so thanks for the questions. Okay, next we're going to talk about some other considerations. So first, energy. So in energy, I know there's some other glass companies that talk about this, so I'm going to be very brief. So there's really two main things I think most people look at when it comes to energy performance. One is solar heat gain. That is preventing heat from entering the building. And normally a triple silver coating is put on the number 2 surface of the glass that will reflect the heat from entering the building. That's probably the most common. And then there's also U value. U value in Florida, at least South Florida, is not as important as maybe like up in Canada or in the Midwest. But yeah, the U value is very important when there are cold temperatures. So, but in terms of these two energy variables, our inner layers really only help you when it comes to UV, blocking the UV. We have thought about adding some inner layers that reflect heat. I don't think our inner layers could ever help with the U values, but that is something we have to consider. But today, I think the number one solution in Florida to lower the solar heat gain is a low E coating on the number 2 surface. Okay, next is security and forced entry. Unfortunately, this is a part of our lives in the United States. So what we've done is worked with the National Glass Association to create a technical paper to talk about different levels of security. So if you look at this table here, if you start on the left, it's basically minimal security or safety. And then as you move to the right, you get higher levels of security up to the final one is ballistic protection, where you can stop a bullet. So this is just a general high-level summary of forced entry and security. Here's an example of a actual crime occurring at a popular store. The video was inside the building. So they have something that's called a ramrod. So they were not able to break into the building. This building actually had our ionoplast inner layer in it. So these criminals gave up and went to the next building, most likely. Okay, there's many tests that you can do for security and forced entry. ASTM F1233 is a popular one. And then 5-AA1 is another one. It's basically you start with a bunch of tools, and you try to break through with one tool. If you don't, you go to the next tool and next. Like in some cases, there's like a fire extinguisher, there's a torch, a flame torch. And sometimes in these tests, you can actually shoot the glass first with a bullet. The bullet goes through, and then you try to do the testing. And I'll show you an example of that. But we have a lot of information for the different tests. In this chart here, it shows, this is the 5-AA1 test showing how far the glass survived the testing. We did different thicknesses of PVB and different thicknesses of ionoplast. And in general, the ionoplast, because it's stronger and more tear resistant, it lasts much longer in the testing for the same thickness. But in this case, want to note, so if you look at 60 mil PVB or 1.52 millimeter PVB, that's what's normally used in a small missile test. It really did not perform very well. It didn't even make it through the brick test. But if you're looking at like a level D glass system with a 90 thousandths 90 mil ionoplast, it made it through the brick test, the kick test, and the tools, the different tools. And if you're looking at a level E system, which is with 180 mil ionoplast, it survived all the testing. It was very impressive. And I'll show you a video on that. Okay, and the last test I want to mention is in 2022, ASTM came out with a test specifically for school security. Before this, school security testing was just using other tests. There really wasn't much consistency on what test was being used, but basically it incorporates 10 rounds of a 5.56 millimeter gun shooting through the glass. So this is not bullet resistant glass. And then you try to break through the glass with a standard device that tries to penetrate the glass. So we've done a lot of testing for this with different interlayers. And in the testing for school security, there's 8 levels. Level 1 is the lowest level. Level 8 is the highest. And what we found was that, in general, the thicker the interlayer, the better the performance. And then also, the ionoplast perform better than the PVB. So, for example, if you were going to use this for the school security test, you were going to use the ionoplast with a 90 thousandths large missile level D with 3 millimeter glass, you would achieve a level of 6. But with PVB, for the same thickness, you'd only be at 4. Okay, so here's a test that we performed. So in this test, the glass was shot 5 times with an AK-47. And then many different tools were used to try to break through. And so on the left will be PVB, and on the right will be the ionoplast. Yeah, on the left, the PVB is already torn.
All right.
Eventually, the PVB does go.
All right. Switch to the wrench.
Switch tools. This is 11.5 minutes. Kind of tired. The owner of the test lab joked that these people were in a stress management program. I think it was kidding. But anyway, so the glass you're seeing here is actually the 180 mil ionoplast that's used for level E impact, or for essential facilities. I'll stop there. All right, so next I want to jump to behavioral health. It's very popular. So we've done a lot of testing with our inner layers to the state of New York standards. The three 2,000 foot-pound impacts from a 200-pound shot bag. Here's a picture showing what the test looks like and what the glass looks like when you're done. And what we found was this is our glass solution in order to pass the test. And we actually use a product called Spall Shield CPET on the inside of the building that includes PVB and a hard-coated PET. Just in case someone tries to break through the glass with their hands, the Spall Shield CPET will prevent any from the hands contacting the glass. So it's a much safer solution. Okay, so some of the questions about tornadoes, ICC 500. There are 6 levels or categories. There's EF0 up to EF5. EF5 is 200 miles an hour. We have done testing with these, but just for the fun of it, I pulled out, okay, which hurricanes have the most recorded tornadoes in them? And I think Milton will definitely I'll be able to add Milton to this list next year. But as you can see, Hurricane Harvey had 54 recorded tornadoes. Lee had 56, Isaac 26, Debbie 24. So unfortunately, during hurricanes, tornadoes can form as well. So this chart shows the difference between hurricane missiles and the tornado missiles, both the missile type and the speed. So once again, level D, large missile, the 9-pound 2x4 going at 34 miles an hour. And once you start doing the FEMA ICC testing, the missile becomes a 15-pound 2x4 instead of 9. So much heavier, much bigger 2x4. And the lowest level tornado was 80 miles an hour. And then EF5 was 100 miles an hour. So it's a 15-pound 2x4 going 100 miles an hour. It's really amazing to watch this testing compared to watching the hurricane testing. So we tested with a few system manufacturers. I mentioned Collier being one, Winco another. I think we did testing with West Tampa Glass. But here's our recommended solutions for the different EF levels. And then hopefully this video works. This is an actual test. This is the EF5 test in slow motion. We did it in slow motion because you see what happens to the 15-pound 2x4 when it hits the corner of the glass. Basically, the 2x4 turns into a bunch of toothpicks. It's the first time I saw this, it shocked me how much. Well, the good news is that there are already some commercial systems available for the different levels. All right, next is I want to talk about bomb blast. The bomb blast is mainly used in government buildings, federal buildings. We do a lot of work with the U.S. Department of State and the GSA, but there's for the GSA level C, it's a 4 psi peak pressure, 28 psi milliseconds. DOD is 6 psi, and then GSA level D is 10 psi, 89 psi milliseconds. So a lot of it depends on how good of a barrier you can have around the building. Because the closer you're on the building, the more destructive the the bomb is going to be. So we did a lot of testing in the past at a test lab in West Texas where there's nothing. An actual bomb is ignited, and you see how your system's tested. But today, most people use in a test lab this bomb blast simulator. All right, so the GSA has different conditions after the testing. Condition 1 is very safe. The glass doesn't even break. To level 5, where the performance was very bad and catastrophic. Here's an example of a building in Florida that has both hurricane and bomb blast requirements. It's a federal building. Okay, there's some. Next, I want to switch over to structural glass. Let me see. There's another question, I think. Okay, the question is testing different than the Texas required testing? No. In general, I think most people that I know that got their systems approved in Texas tested either to Miami-Dade or to the Florida building code, and then they just shared the test results with the state of Texas, and then they had to fill out the state of Texas paperwork. So there's not a separate test for Texas, but there is different paperwork for Texas. And the next question, is there a best option for single family residential, or are there existing residential window manufacturers incorporating the ionoplast interply? So I'd say in general, most system manufacturers use PVB when they can because it's less expensive. But I think whenever the glass sizes are big or the design pressures are high, that's when ionoplast is normally used. Okay, so here's some really nice projects in the Dali Museum in St. Pete. This is one of the first structural glass hurricane-rated systems that I was aware of. Here's a nice resort in the Bahamas that used ionoplast. The last question someone asked about ionoplast. So in this building, the owner decided to use ionoplast all the way up the building instead of the first 30 feet using ionoplast and PVB the rest. So in this case, they decided to just use ionoplast all the way up the building, but that was their choice. Okay, there's many different structural glass projects. I'm gonna try to zoom through these. But if you're ever in Singapore, the Marina Bay Sands, very nice. In Paris, there's the Louis Vuitton headquarters, in the Shanghai Tower in China. The company that really started the structural glass revolution was Apple. For their stores, they had nice openings like the Cube. They had glass stairs, glass floors, glass railings. On the bottom right is the Amazon building in Seattle. But there's now structural glass is used on top of buildings, and it actually becomes entertainment. So the top left picture is the new building in the Hudson Yards. It's an observation deck, the tallest observation deck in North America, overlooking New York City. The bottom picture is the Space Needle in Seattle. And then on the far right, that is a glass cube off of one of the tallest buildings in Chicago, where you can walk off the building and stand on the glass. But here's someone decided to put a glass slide on top of one of the tall buildings in Los Angeles. And I'll show you a quick video. So this is all structural glass with ionoplast. So it's actually pretty scary if you're afraid of heights. Another one is, this is a suspension bridge. So with this bridge, when it's windy, it swings. which makes it even scarier. They have a really a glass floor on it. So there's an extra piece of glass from the project. So the owners decided to break the extra piece of glass on top of the bridge just to show you how strong the glass was. So even if the glass did break, you would be safe. And then here's a nice project in Bangkok. So we're starting to see these observation decks, these glass floors all over the world. Okay, next is sustainability. Like most companies, we have sustainability goals to get to zero by 2050. Our company recently completed our EPDs for our PVB and ionoplast interlayers. If you're interested, let me know. What we found was in general, the ionoplast as a interlayer for the same thickness has lower carbon footprint than PVB. Here's some of the results from our life cycle analysis in EPDs. I want to talk about structural glass. So structural glass with ionoplast, just using the ionoplast for the same interlayer thickness, you reduce your carbon by 19%. But because of ASTM E1300, structural engineers can design the glass to actually downglaze it. So like, let's say you have a glass railing, it requires 8mm glass. With PVB, you might be able to get by with 6mm glass with the ionoplast. So actually you can reduce the carbon footprint of the glass itself. With structural glass, you can eliminate some of the framing as well. And also when the glass is lighter, you don't need to support as much weight in the building. But I'll show you an example of this is the Shanghai Tower. This is the fifth tallest building in the world. I'm sorry, third tallest building in the world. They decided to use structural glass with century glass instead of PVB, the whole building with a double wall, and they were able to reduce the carbon footprint by 20% just by switching the interlayer. And here's an example of a glass railing where switching from PVB to century glass, you're able to reduce the carbon footprint by 24%. And I mentioned with structural glass, you can get by with less framing. On the picture on the right is a Foresight captured glass railing with metal. And the picture on the right, there's no framing. It's only supported in the base. So in this case, you're using less metal. So less metal means lower carbon. All right, so at that point, I'll stop here. Let's see. Let me see. We got 2 minutes left. All right. First of all, what type of glazing was used in space vehicles? I guess it depends. I believe PVBs and ionoplasts have both been used in the space vehicles. It depends on the requirements. But if you want some more information, I could cover that later. The glass bridge at Hunter Art Museum, structural glass, correct. It was coefficient of expansion, or was it coefficient expansion or UV? They replaced the metal. So unfortunately, I'm not familiar with this project. I didn't hear the glass cracked. So I don't have an answer for that one, but I could look into it if you'd like. All right. 1 more minute. Is ionoplast glass fire rating? No, it's not. Both PVB and ionoplast are not fire rated. You have to, but in the hurricane region, we do work with the fire rated companies that use our interlayers when there's fire rated and hurricane requirements both. All right, and then is there a skylight option that's rated Class E? I'm sure there is, but if the skylight is above 30 feet, you wouldn't need E. So, but there's no reason why you couldn't have a skylight that's level E. Okay, is there a recommended glass recipe for glass facing water or exposed salt from the ocean? Yeah, especially if if the glass has exposed edges, we always recommend the ionoplast because it's very durable when it comes to sun, rain, salt, uh, heat, humidity. So that would be our recommendation. So I think I'm out of time. We'll stop there. Thanks, everybody.